So guys, we are going to continue the discussion with respect to simple linear regression. In our previous video, we had discussed about cost function and how we could actually find out different cost function by changing our theta 1 value. And we also saw that we could form a gradient descent curve, which is this kind of curve. And our main aim is basically to come up to this global minima, because in this global minima, when come near this global minima, that basically means we are very much near to the best fit line, because our cost function is quite minimal. But when we are trying to find out our cost function, we were randomly changing our theta 1 value, which is our slope. First time I took 1, then we took 0.5, and then I selected as 0. This is not an efficient technique. So I told you that we will be discussing about a convergence algorithm, which will actually help you to initialize one theta 1 value, and automatically, based on this gradient descent, it should be able to, increase the theta 1 value or decrease the theta 1 value. So let's understand the convergence algorithm. So over here, I'm just going to mention the convergence algorithm, which is super important for the optimized technique. Okay. So this is the convergence algorithm, and this convergence algorithm main aim is to optimize the changes of theta 1 value, which is my theta 1 value. Okay. Which is my slope. Okay. In this particular problem statement. So what does convergence algorithm basically say? Convergence algorithm basically say repeat until convergence. Okay. Until convergence basically means until we reach the global minima, this specific global minima point. Okay. This specific global minima point. So here you can see that when we reach this global minima point, we got the best fit line, or at least if we come near this, we will probably get the best fit line. Okay. So repeat until convergence. And here I'm just going to write a simple equation, which is like theta of j. Okay. Theta of j is equal to theta of j minus, okay, alpha. Alpha, I'll talk about this, what exactly is alpha. And then we are going to basically write derivative of theta j with respect to the j theta 1. Okay. Or here I'm just going to basically write theta j. Now what exactly this is? Okay. Now try to understand. Okay. This theta j, initially we'll initialize something and then we'll try to find out the cost function. And obviously you know that with respect to the cost function, how does the cost function basically is created? So here if I initialize and create a graph with respect to theta j and j of theta. Okay. So this is what we created, this graph right over here. You could see this, right? You know that we usually get this kind of gradient descent, right? Let's say with respect to, and this equation will definitely work. Okay. Well, this equation is definitely going to work. That basically means this equation actually helps us to change our theta value, specifically in our problem statement, the theta 1 value much more efficiently. So we are going to change this theta 1 value much more efficiently. How? Okay. So let's consider my theta j value is somewhere at this specific point. So j of theta will be coming somewhere here. Okay. Let's consider that this is the point that I'm going to probably get. Okay. Now you need to understand what exactly this is. Okay. Derivative of theta j with respect to j of theta j. Okay. With respect to that. In short, we are just trying to find out the derivative of this specific point. Now, whenever we say derivative, in short, we are going to calculate the slope. Okay. Now, let's say we have initialized one theta 1 value randomly at this point. We got our j of theta at this particular point. Now, our main aim is that we need to come to this specific point. Okay. Because why this specific point we really need to come? Let me just draw it much more betterly. So let's draw this curve like this. Our main aim is to come to this point. Okay. This point is basically my global minima or near to this point. Recall this point, if I come, which is my global minima, then we are basically getting our best fit line. Okay. Now, initially my theta value got initialized at this particular point. I got j of theta, but I have to make sure that I come to this specific one. My j of theta should come to this point so that my cost will basically minimize, right? Now, my theta of j, how do I make the changes such that my j of theta will come over here? That we are going to look at. Now, as soon as it comes over here, this derivative of derivative of j of theta with respect to theta j is nothing but we are trying to calculate the slope at this particular point. That is what derivative specifies. Okay. Now in this particular case, how do we understand what is the derivative of this particular value? Okay. In order to find out the derivative, one important thing that you really need to find out is that whether this is a positive slope or negative slope, because derivative is nothing but we are actually trying to calculate the slope. Okay. We are trying to find out the slope. Okay. So for this particular point, what we do in order to calculate the slope, we create a tangent line like this. Okay. Let's say with that we are creating this tangent line. So this tangent line will probably get created like this. Okay. Now, when we are creating this tangent line, first of all, you need to find out that see the right side of the line. Okay. Because one important thing that we need to find out over here that whether it is a positive slope or a negative slope. Because if we are able to find out whether it is a positive slope or negative slope, then we will be able to understand whether we have to reduce our theta j value or whether we have to increase our theta j value. Okay. Now in this particular case, at this particular point, if I really need to understand whether this is a positive or negative slope, just see the right part of the line. The right of the part of the line is facing downwards. Okay. If it is facing downwards, we will be saying this as negative slope. Now, when we say negative slope, that basically means whenever we try to find out the derivative, this value is going to be negative. Okay. This value is going to be negative. So what we are going to do is that we will just suppose I get a negative slope. So in short, I will write theta j is equal to theta j minus some learning rate alpha. I'll talk about why alpha is used, and this will be my negative value. Okay. This will be my negative value. So in short, this basically indicates that my theta j, I have to probably add with some positive value, right? Because negative into negative will be positive. So I have to add this specific positive value, and it is true over here because I need to basically increase my theta j value. So if I do this iterative process again and again, wherein I'm continuously getting a negative slope, that basically means I have to increase my theta j value so that I reach my global minima. So this equation is going to add some value into my theta j. How much value? We don't know, since this is an iterative process. Our main aim is to basically optimize this process of selecting different theta 1 value, right? So in this way, what will happen? We are incrementing or we are increasing our theta j value. Then in the next theta j, whatever will be my cost function, again, that specific point will come over here. Let's say it is coming over here. Then again, I will try to go and find out this slope. Again, if it is a negative slope, we keep on adding. So slowly, you will be seeing that we will be able to converge it towards the global minima. Okay, this is one process. What about now in this particular case, I got negative slope. What about if I get another point over here, and this particular point is actually a positive slope? How do I get a positive slope? Because if I try to create a tangent line, just see the right part of the line. Right part of the line is pointing upwards. So this becomes a positive slope. Now in the case of positive slope, I really need to decrease my theta j value, right? Let's say that initially my theta 1 was over here, and I got my j of theta 1 over here. So here I have to decrease it. Okay. I have to decrease it. Then only I'll be able to reach the global minima. So does this satisfy? Yes, it does satisfy, because if I write now theta j is equal to theta j minus alpha, and now this is my positive slope, right? So here with respect to this, whenever I try to find out the derivative, it is a positive slope. Now whenever it is a positive slope, all I am actually doing, I'm subtracting with some value, some positive value. When I subtract with some positive value, that basically means I have to basically decrease my theta j value. And if I continuously perform this process, after some time, you will be able to see that I am going to basically come at this specific point. Okay. So obviously this convergence algorithm will obviously work, because what I am actually doing is that we are trying to calculate the slope in such a way that where if it is a negative slope, the theta j value, it is going to increase. If it is a positive slope, the theta j value, it will decrease. Okay. So this is what is a convergence algorithm all about. Okay. Now there is one important parameter that we did not discuss about, is something called as alpha. So what exactly is this alpha? Alpha is nothing but this is specifically a learning rate. Learning rate usually is a smaller value that is basically initialized. Let's consider the learning rate that may be initialized for my problem statement is 0.001. Now, what is the importance of this learning rate? Learning rate controls the speed at which the convergence should happen. Okay. If it is a very, very small value, then it will probably take more time to converge. If it is a very big value, then it may happen in such a way that it may continuously jump here and there and it may never converge. So it you always have to make sure that you try to select a smaller value, but it should not be a very, very smaller value. It should be like 0.001, which is a very good practice that we should try to select. Okay. In simple linear regression only, alpha is equal to 0.001 in a scalon library that we use is basically getting selected. So if anybody asks you in an interview, like what is the importance of learning rate? You can definitely say that it actually controls the convergence, right? How slow the convergence should happen. Okay. So this is what it basically says, right? So I hope you have understood about the convergence algorithm, and this process continues unless and until we don't come near this global minima and we don't basically converge over here. As soon as we converge at this particular point, you will be seeing that we will try to get the best fit line, which is this specific line with respect to any kind of data points. So this is the most important optimized technique that we should use with respect to the convergence algorithm. Okay. And this basically gets applied in an amazing way, and most important interview questions when you're learning machine learning algorithms. So yes, in the next video, we are going to also continue and understand about the performance metrics. Thank you.